Hey y'all, CB here once again at NBS Welding. We got field work we got to head out and do today, but I've got a little job that was dropped off here by a buddy of mine. This I think it come off a skid steer. It's like a fan shroud bracket or something that's been broke, and I want to use this to show a few concepts that are just what I would call basic repair concepts, and they're things that the novice welders and guys that are learning welding might not really think of. You get you a machine and you start striking an arc and running beads and stuff like that, but there's other things to consider, and one of the things that kind of comes natural to me over the years of welding is really like heat management and the understanding that where you start welding is always a thick spot. And as you weld, the material temperature increases. And at the very end of your weld, that, I hate to say the word, but what most guys call it a cow pussy, it's a crater where you stop welding. That is often on small parts, that's often a thinner spot. And it's a place where cracks can start, and it's something that, the concept more or less is when you're welding on, you have a small piece of material like this. The concept that comes natural in my mind that the novice welder needs to learn and doesn't often think of is you always want to start welding where you need the least amount of heat, and then finish welding where you need the most. So one of the concepts of repairing something like this, when you're going to weld this together, if you just fire up right here and run all the way to the other end, what you'll find is you'll have a thick start where you started welding right here. And then when you get over here to the end, you can't hardly deposit enough material to make it thick because this little bracket is heated up and it's got hotter and hotter as you've went. So one of the concepts that you need to think of if you're welding on something like this is like you might start here and weld that direction and go just a little past half and then stop. Go to the other end and make a restart. See, out here on the end, it's going to be so easy to get the edge of that so hot that this is a good place to start. Remember, starts are cold and thick. You're super hot where you stop. So you might want to start here and weld across something like this and go a little more than half and stop, and then make a restart on the other end and come back. And do a little bit of an overlap on that really hot end of your weld where it's wanting to be thinner. Another term I use a lot when it comes to doing repairs is I puzzle piece things together. Now, a lot of people will see something like this broke and they immediately want to grab it and bevel it. If you grab something like this and bevel it, it's not going to puzzle piece. Look how perfect that puzzle piece is together when I put it together. If I want this bracket put back together just as perfectly as it came apart, what I'm going to do is I'm going to hold it together just like this. See how it's puzzle pieced? It's puzzle pieced together, and it's telling me that this is exactly where these parts were when they came apart. And that's how I want to tack them. And I can tack that like that, and then I'll take a grinder or a torch with a scarfing tip or a carbon arc or whatever's required. On something this small, just a grinder's going to be fine. But I'll go in there and I'll do my beveling with it tacked together. And in most cases, like on this, I'll go ahead and weld one side. And you want to think about which side you weld on something like this, because look, the inside of this would be tough to grind on, but the outside would be easy. So what do you think we should do? Hey, it's simple. I want to puzzle piece this thing together. I'm going to put a tack on each end. I'm going to weld a bead across the inside. Then I'll go to the outside, take my grinder, and I'm going to grind into that until I've hit the back side of the weld that I put on the other side. Then when I weld that up, I know I've got a full penetration weld. Now, doesn't matter if you were going to do this with MIG, stick, flux core, TIG, whatever you want. I'm going to be using the Millermatic 252, the one we call the little bitch. My neighbor named it the little bitch because one of my Millermatic 252s has always seemed to weld better than the other one. You run into that with machines and you just can't explain why. I've found with the little bitch, I quit running 035 wire in it and I leave 030 in it. So I've got 030 solid MIG wire in the little bitch. And then I've got 035 solid wire in my other Millermatic 252. So on the bigger stuff, I use it. And the older one that welds better, that's got the 035 wire, is the one that's got the spool gun on it all the time. But the one I'm going to be using on this is got the smaller wire. So I'll be running a little bitch with 030 solid MIG wire and a mixed gas. So that's a 75% argon, 25% CO2. This appears to be powder coated. If what's on here's paint, it's some really, really good paint. But I don't want to sand it or grind it before I puzzle piece it together because I don't want to change the shape of it. What I'm actually going to do is I'm going to try to power brush the heck out of it. So we'll put it in a vise. We'll power brush it really harshly and get as much paint off out of the weld zone as possible. 1/4 inch to a 1/2 inch out of the weld zone's fine. I'm not going to clean the whole bracket off. If my buddy wants to do that and repaint it, he can do that. And then I'm gonna puzzle piece it together. Like I always say, you know, I'm going to get it perfect because I can tell where it goes. And I'm going to tack each end. I'm going to put a tack here, put a tack here. Then I'm going to go to the inside and I'm going to run a bead across the crack. Then I'm going to take the grinder, bevel the outside, and weld it up. And we'll see what we got. Now, I don't know if there would be any, I seriously doubt there would be any clearance issues with the weld on this. Looking at the bracket, I think we can leave the weld there. And my buddy that is having me to fix this, I think he's got an angle grinder. So I'm not going to be grinding any of the weld off. And if he goes to assemble this and realize he needs a grinding spot, I think he can do that. On any repair, any weld you don't have to grind, I wouldn't grind it. There may be times with flex or whatever that it would make sense to grind it off so that it's the same thickness as everything else, but more often than not, the more material that's there, the better. So if you don't need to grind it off, don't. Now I understand a lot of hobby welders will do some grinding because they're trying to make it look a little better. And if you got some knots and knobs you want to knock down, you know, that's fine. Hopefully I don't have that as a problem here. So let's fix this and see how it turns out. Funny how somebody will call something a name and the name just sticks. But on this particular Millermatic 252, the one we call Little Bitch, my neighbor called it that because he just never could get it dialed in as good as the old one. And he'd keep messing with the voltage and the wire speed and never could get it where it satisfied him the way the other one did. But it does a great job. I just want to show, I was with the 030 solid wire and a 7525 gas, I was at 18.6 volts, 251 inches a minute of wire. And there's a couple concepts I want you to think of on this job that I hope you saw as I did it. One of them is the puzzle piecing the parts together. That gets parts put back together just exactly where they go. Now, if you can get the parts put back together exactly where they go, there's nothing wrong with beveling them beforehand. I'm not saying that's wrong. Me personally, I would rather puzzle piece them together and see them fit just the way they came apart and tack it that way. And then, you know, back gouge or grind or carbon arc or scarf or whatever it takes to remove the material needed to get the weld in there that's needed. The other concept that I think is important that people don't think enough about that we can learn from this is, I hope you could see how before I just took off and finish welded across that bracket, I went to one side, I made a start, and I started welding across it. And then I kind of tapered that weld down and stopped about midways or so. Doesn't really matter where you stop, as long as you're putting yourself in a position where you can make a nice overlap. But the concept of what I was doing is, by making that heavy, thick start on that side, and then going to the other side and making a restart and coming back, that means when I got to the end of that weld, when the material was just raging hot, I had a nice heavy edge to hold that weld that I was making. Now, what I'm trying to say is that if I hadn't done that, what would have happened most likely is, as I welded across, the material would get hotter and hotter. And when you get to the end, it's so hot that you're actually making a thinner weld or overheating the material or burning through. When some people, you might hear people say that there's no such thing as welding too hot. There is. Welding too hot means you're unable to deposit weld bead. If you're burning through, or it's so hot that you can't make the weld in the shape that you are making, then you're too hot. And one of the ways that you can control that is by having some extra material there to hold that weld. I power brushed this off. We'll take another look. So you can see on my final weld, this is where I started on this side and came across this way. But before I did that, I made a start right here and I welded that way. And I went maybe a third of the way across there, and then I started tapering it down. And after I did that, then I was ready to start on this edge and go all the way across. So that's got us fixed up on that bracket. I want to thank y'all for watching. We got field work to do today. We're late getting out there. I was at the gym too long this morning again. But we're going to get out there and get the field work done. I'm glad that you were able to watch and be part of this repair. Little job, but I think a couple of really important concepts there, especially for the novice welders. So I want to thank y'all again for watching. I hope you're enjoying the channel. Like, comment, subscribe, share, help me out. Do whatever you can. And remember, like I always say, y'all learn to work with what you got. That way you always have everything you need. Hey y'all, CB here at NBS Welding. We're in the break room doing a quick merch video. For any of you that are interested in merchandise to help support the channel, we got the stickers. Small size sticker, like a hard hat size, $3. Got the bull logo, NBS Welding, got the name and phone number. The medium size, $5. And then the big bumper sticker, $10. Now, there's no shipping on the stickers. We can put these in an envelope. It's pretty simple, no problem. Next thing is the shirts. We did have some trouble with the shirt order. We just got proof that they fixed the problem they had, and they sent us the proof. So this is, they got it right where the NBS Welding logo's on the chest, then the great big NBS Welding on the back. with the American flag on the sleeve, the way we like it. $25 for an NBS welding shirt. These will be here, supposed to be here September 5th, so we're taking orders. Got a couple orders already. Wayne and Mike, you guys, you're going to be getting your shirt. It's coming. Next thing I want to talk about the cup. My buddy tried to make these cups, and I wanted the QR code on the cup, and he couldn't figure out how to make it work. He made me cups. The QR code wouldn't scan. He said he didn't. He finally gave up. He wanted to give me my money back. I said, no, not all of it. We're going to share the responsibility. Anyway, he gave me a portion of my money back. I gave him enough money to cover what he spent, but I continued to work on it, and I got it worked out. I don't think my cups are as nice as his, but they work. And here's the thing. The QR code's got to be on the top where it's flat. If it's on the radius on the side of the cup, it's not going to scan. It's got to be on the top. I figured it out. But we got the cups. NBS welding with the bull logo. Got less yakking, more tacking. Pretty simple cup, but like I said, I made this myself. I bought the cups and the materials. I put it together. Had to make it work. I didn't want to quit on it. Now I want to talk about this real quick because this something come up. A way for that you can give to the channel is through Super Thanks, through YouTube. And our guy Corey has given $100 Super Thanks repeatedly. And I keep thinking like, man, this Corey has contributed so much. I really want to do something to thank him, and I couldn't think of what I could afford to do. And I remembered these coins. Now, I had these coins made when I was making good money working in the oil field. And what this is this is 1 troy ounce of 0.999 fine silver. It says NBS Welding. It's got the name and phone number and the designation 0.999 fine silver. So this is an ounce of pure silver. And if you turn it over, it's got the bull logo on the back. This coin, I'm sending this to Corey to thank him for all the super thanks that he's given. There's one thing that is, there's two things about super thanks. It's super easy for you guys to contribute to a YouTube channel through super thanks because you can go on your device and you can hit super thanks and boom, it's quick. It's easy for you to do. The problem with super thanks is YouTube gets 30% of that money. So out of a $10 super thanks, you're giving YouTube $3. But it's kind of like that with the merch too. If a shirt's $25, we have to buy the shirt. So I have to put money in, you know, there's money going somewhere. Anyway, this idea came up to give Corey a coin. And it's got a real nice little plastic case I'll show you. I just put it back in the case. That keeps them from getting fingerprints all over it. Here's the thing. When I got the idea that I was going to give Corey the coin, I wanted to offer it to everyone. So if you're interested in a coin, $50. Send Tina an email. nbswelding@aol.com. And thank y'all.